Dear students, welcome and thank you for tuning in to this video. This is the second video of lecture 20 in which we are talking about the center of gravity and centroid as part of statics and dynamics with me, Dr. Loay Al-Zube. In this video, we're going to continue our discussion about the concept of the center of gravity, which we explained in the previous video. So we talked that the center of gravity can be located actually by understanding the sum, or which is the point where we have the sum of the moments due to the individual particles that makes up a body is equal the same as the amount due to the resultant weight located at a point G. And we also have discussed in the previous video that the sum of moments due to individual particles weights that makes up the body about the point G, which is the center of gravity, should equal to 0. So having these two conditions in mind, we move and continue our discussion by saying how can we calculate actually the location and determine the location of the center of gravity, which is G. So the location of center of gravity is measured from the y-axis. If that's the case, we can determine that by equating the moment of W, which is the resultant or the total weight of the object, about the y-axis to the sum of moments of all weights of the particles that makes the body about the same axis. So what do we mean by that? So remember that we'd like to equate the moment. So the moment, we know that from the previous discussions, that moment equals force multiplied by the distance. So if I'm trying to locate the moment away from the x-axis, I'm going to say my force is the weight of the entire body, which is the total weight, multiplied by the distance from the x-axis, is going to equal the summation of all small weights, small particles. So this is one of the small objects that makes up the entire body. We have infinite number of these, and multiplied. So this small, infinitesimal small dw, which represent the weight, which is a force, multiplied by the distance x tilde, that's the distance from the y-axis. Summation of all of them, which is the integration, should equal w, the total weight, multiplied by the distance from that axis. So this is what we meant by equating the moment of w, right, about the y-axis. That's how we look at this, equal to the sum of moments, that's the integration, of the weights of the particles dw are about that same axis, which is x tilde. This can be done the same actually for the y and the z axis. So we will end up with three equations that actually we can use to find x bar, y bar, and z bar, which are the locations of the G, right? So the end goal is to find x bar, y bar, and z bar, which are the coordinates or the location of the point G, which is the center of gravity. Now, to find these, if we look at this formula, you can say that x bar equals the integration of x tilde dw divided by w, and w actually is the integration of dw, right, which is the integration of the infinitesimal partial weights. So this is our formula in finding x bar, which is the x coordinate of the center of gravity. So if we did the same for all of these, x, y, and z, we're going to end up with those formulas. So the center of gravity can be identified with respect to the x, y, and z with these three formulas. X bar equals the integration of x tilde dw over dw, which is the weight actually. Same thing happened for the y and the z. You just change the whatever we are integrating here. For the x we have x tilde, for the y we have y tilde, and for the z we have z tilde, and everything is the same. And then x tilde, y tilde, and z tilde are the coordinate of G, which is the center of gravity. That's what we're looking for, right? Okay, I hope that clarifies how can we determine this, because we're going to apply it in a couple of examples later on. One more thing that we'd like to introduce after understanding and introducing the center of gravity is something called the center of mass. And the center of mass is actually similar to, to find the center of mass, we would like to find locations, right? Again, it's x bar, y bar, and z bar. And it's the same concept as the center of gravity. Instead, but we were going to replace W, which is the weight, now with the mass, with M, in these occasions. So those are the occasions for the weight. This is the center of gravity, it's G, and we need to find the center of mass now, which is Cm, right? Center of mass. So what we do is we replace every W with a mass, with M, and this is what you end up with. So those are the three occasions that can help us to identify x bar, y bar, and z bar. All right. So keep in mind, when we have x bar, y bar, z bar, those are the coordinates of the center of mass or center of gravity. X tilde, y tilde, and the z tilde are the coordinates of the dw or the d mass, dm, which is the infinitesimal small amount of weight, or the particles that makes the weight, or the particles that makes the mass. Similarly, actually, we have three other important quantities that we can identify, which are related to something called the centroid. So we have something called the centroid of volume, centroid of area, and centroid of length. And again, we can calculate them similar to what we did with the center of gravity and center of mass by replacing W with the volume, area, and length. And that's how we find the centroid. So this is something to distinct between the center of gravity, center of mass, and the centroid. I would like to also to explain a little bit more about the centroid. So what is the centroid? So center of gravity, center of mass, and then centroid. So we need to introduce a couple of concepts about the centroid. So here's the thing. The centroid C is a point defining the geometrical center of an object. So this is different from kinetic quantities like forces and moments, or center of the gravities or masses. So it's a geometric quantity, and it defines the center of an object. And so we can identify the center of an area, center of volume, or the center of a line, actually. So the centroid coincides with the center of mass or the center of gravity only. We have a condition here. If the material of the body is homogeneous, which means the density or a specific weight is constant throughout the body. That's the only condition that we can say where the center of mass or the center of gravity is coinciding with the center of the centroid of the object, regardless if it's the area or the weight or the area or volume or the length. If an object has an axis of symmetry, then the centroid of the object lies on that axis. So if you look at this cylinder here, that volume, we know that we have an axis of symmetry around the z-axis. So our center, or the centroid, is probably going to be located along that line. Another concept of the centroid is that in some cases the centroid may not be located on an object. So if I'm looking at this object here, I have a linear structure as a line, right? And if I want to find the centroid of that object, the centroid is in point C, and point C is not located on that object, so it's out of that object, and that's actually common if you're looking at center of line. I hope that this video introduced the concept of the center of gravity, center of mass, and the centroids of volume, area, and length more, and clarifies to us that we're going to do integrations because we are going to account for a lot of small objects that can make up our body that we would like to analyze and find the center of gravity or center of mass and the geometrical centroids for it. In the next video, we're going to look at the steps that we're going to take in order to solve a problem and identify the center of gravity or the center of mass or the centroids. And then we're going to have another video, or probably in the same video, to solve problems and apply what we learn into a real, world problem, or a classical or problem, an exercise problem that will clarify the whole, bring everything together, all the concepts that we have discussed. Thank you for watching. Until the next video. Bye.